Mic check. I think we're good. We should be good. Okay. Let's go ahead and get started here. Okay, so welcome back to CS196, everyone. Let's go ahead and get straight into the slides here. So I wanted to start off by talking about a couple announcements and a little bit of planning for the next couple of lectures to give you guys a heads up of what's gonna happen and what's gonna go on. So first things first, I want to reiterate an announcement that we made on Piazza because it is incredibly important and I want to make sure that nobody missed it, even though you guys should be keeping up with these Piazza posts. So the Django homework is changed. The part 1 is the only part that's going to be required of you guys because a lot of people ran into issues with their Windows environment setups for part 2. So we are offering part 2 as extra credit now. So if you finished it, congratulations, you have 1% extra credit now. And if you were running into that environment issue, we know that you guys probably spent countless hours synced into that. So we want to give you guys like 0.5 extra credit if you guys can show that you ran into that error with like a screenshot or something. So that's basically long story short about that announcement. But go on Piazza, take a look at what we said. So that's it for that, essentially. Go on Piazza, look at what we said. And so the next lecture, the one that is going to be on Thursday, I want to make sure you guys know this. It's actually not going to be on Twitch. That lecture is going to be a bit different. Some of you might not know this, but CS196 is sponsored by IMC Trading. Look into who they are if you're interested, but essentially they are a high-frequency trading company. And so representatives from IMC Trading will be talking to you guys and being able to answer all of your questions that you guys have for them. They'll have a lecture for us on Thursday, and that'll be through Zoom because that's how they wanted to deliver it. So this will be, as far as I know, our only Zoom lecture, so don't worry about us transitioning to Zoom. I just wanted to make sure you guys knew what's going on there, and pay attention to the announcements, of course. And so after that, we'll be back on Twitch. I'll be giving you guys a lecture 1 week from today, according to the schedule, about some advice that I have for internships, how to go about getting an internship. A lot of you guys have been asking me things about, internship advice. So that's going to be basically my tell-all of everything I have to say about how to get an internship. It's going to be more of a professional development kind of lecture. After that, we're going to be starting the Rust programming language. So that's going to be a big shift in the semester. We're going to leave Python behind for the most part. We're not really going to be using Python as like the driving tool to deliver the concepts in the lectures anymore. We'll be teaching you guys this new up-and-coming programming language called Rust. And also, shortly after we start Rust, we are going to have midterm presentations, which we will reveal more information about closer to the date. But talk to your PM, your project manager about this. They will be coming up very soon. It's going to essentially be you guys presenting to us on what you guys have so far. Nothing too stressful. You don't need to, have your whole project done or something. We just want to check in on you guys, see what's going on, and it's worth a very small amount of your project grade. So that's a little bit of a heads up of what's to come. So objectives for today. So like I said, this is going to be our last lecture using Python. Next lecture is going to be, professional development with IMC Trading. The lecture after that is going to be more professional development about, my advice for internships. So today, essentially the last lecture we'll have using Python for a very long time. We might come back to it at the very end of the semester. So what are we going to be talking about today exactly? We're going to be covering a few things. First things first, we're going to be talking about the differences between client-side rendering and server-side rendering, and I'll give you guys the rundown on what that is. Once we get that terminology out of the way, once we kind of clarify what this exactly means, we're going to be talking about RESTful APIs and how to build one using Flask. So you guys by now have a decent understanding of what's going on with Django. I want to give you guys a better understanding of, the different patterns that Django uses and contrast that with a different way of writing applications, and we're going to be using Flask as the driving framework or tool to do that. So first things first, let's start with what I talked about, which is server-side rendering versus client-side rendering. So what exactly is this? Well, when you go onto a web page, what you're seeing needs to be rendered in some way. The HTML files, the code for the website needs to be rendered in a way where the computer, the browser understands, what's going on, and it can actually be able to display to you, the user, what the programmer wants it to see, right? So the content needs to be rendered in some way, in some place. And so one location of rendering these files is on the server. So what do I mean by that? Well, Django is actually designed for server-side rendering. So you guys have actually already done this. And what server-side rendering means is when you go onto a page, it'll right away make a request to a server. And once that request is done processing, your browser will get that HTML fully rendered and displayed on the screen. So if you decide to go onto a different page, if you click on a link, for example, to go to a different route on the website, your browser will once again make another request to the server, and it'll basically ask the server, hey, can you render this page for me? You'll get the rendered HTML back, and you'll be able to display it onto the screen in the browser to the user, right? And so since the dawn of time, this is a little bit of a quote from an article that I read. So since the dawn of time, the conventional method for getting your HTML up onto a screen was by using server-side rendering. It was the only way. You loaded your HTML pages onto a server, then the server went and turned the useful documents turned them into useful documents on your users' browsers. So what that means is server-side rendering is how things have always been done. You go onto a web page, it asks the server somewhere, hey, can you render this HTML? And it'll spit back something that your browser can actually understand, and it'll display it for you as the user. Now, another thing that's important to note is that we said that this is something that's been since the dawn of time. And so if you remember, websites were not always as complex as they were now. Since the dawn of time, this is what websites looked like at the dawn of time. They were fairly simple, fairly static, nothing too crazy going on. So, rendering this essentially wasn't that expensive, and, you could kind of get away with server-side rendering in a lot of ways. So, what's important to note here? Every single time that you load a page using server-side rendering, again, this is what you'll see in a framework like Django, the entire page is rendered on the server every single time. And so what does that mean? Well, here is a little bit of HTML. You don't really need to understand or know HTML super well to get this example, but take a look here. So let's say we have this text written in HTML that we want to render. So this is an example of my new website, and right under that we have a link. And so if I were to go onto this web page, it would ship this HTML off to a server, and it would render it, and we would get back what we need, right? The browser will be able to display it for the user. So let's say we have this HTML file, extremely similar. The only difference is that we have this right here that says, instead of that link that we were talking about, this is some more content from the other HTML. So if we were to render this page, it would, despite having only one line difference, very, very minimal difference, it would render the entire page. Because every single time you go onto a page with server-side rendering, it'll ship a request off to the server and render it every single time. So the browser will ask for a new page from the server and re-render everything. And so if you haven't noticed, things can get a bit slow if you do this. This is a major con of server-side rendering. If you have to ship off a request every single time, things can get a bit slow, as you might imagine. So now let's contrast this with client-side rendering. What is client-side rendering? So instead of rendering the file in the server, you'll be doing it in the client, aka the browser. So this is a relatively new approach of doing things. Like we said, Server-side rendering was since the dawn of time, but this is kind of new school. It's a relatively new approach to rendering websites, and it didn't really become popular until JavaScript libraries started incorporating them into their style of development. And some notable examples of these libraries from JavaScript are Vue.js and React.js. You don't really need to know what they are, just know that they're kind of, pushing this new style of rendering your HTML. We have some questions here. I have no idea what that is to the person that asked the question in the lecture chat. Gets by JS. I'm not sure what that is, to be honest. But I'm going to go ahead and continue here. So one of these libraries that we talked about, Vue.js. So if we were using client-side rendering, so the rendering that is happening on the browser rather than the server, essentially what would happen is you would render the whole website using JavaScript inside of the browser. And if we used Vue.js, Vue.js will make sure that only new content is rendered. So if we contrast that with the server-side rendering, we'll see that in a situation like this where something very minimal is happening, the library will make sure that only the new things are re-rendered rather than the entire page, rather than shipping a request off to the server. So let's talk about the pros and cons between the two. So I'll actually remove my camera for this. So let's compare and contrast them. There are benefits and there are cons to using both server-side and client-side. It's not like it's a completely black and white situation. Some things are better for certain things. So server-side rendering, what are the pros of it? Well, search engines can crawl the site for better SEO. So SEO is search engine optimization. This is basically what helps you show up on Google when people search you. And so the reason why it's better for SEO is because, the way that this score is calculated is web crawlers go out and basically crawl the web. And so with server-side pros, you can guarantee that the entire page will be rendered when the web crawler actually goes on there. Whereas with client-side, you can't actually guarantee that the entire page will be rendered whenever you go onto the page, like right from the start. Server-side is great for static websites because, like we said, websites used to be fairly simple. And they get a bit more slow when you get like these super large web applications. The initial load page is a bit faster, and the reason why that is because in contrast with client-side, the initial load page is a little bit slower with client-side because you actually have to make sure all of the JavaScript is rendered before you can actually display everything on that initial load. Server-side cons. We have very frequent server requests. This is very important. Like I said, every single time you want to render a page, it's shipped off to the server. So they're very frequent server requests. And overall, you can say that in the general case, the pages will render pretty slow because of full page reloads and etc., right? So client-side pros. We could say that, the general experience with a client-side rendered application is that things get typically more complex. Great for web applications, very complex, large web applications that do more than just like serve some information to the user. We can say that they're generally pretty fast because we're only rendering things that are new rather than everything every single time. But the cons here are that we'll have pretty low SEO if not implemented correctly, in contrast to the server side. And the initial load might require some more time because, like I said, the entire JavaScript file has to be rendered on that initial load. And in a lot of cases, it would require an external library. So there's a lot of information there. Honestly, it's not super important to understand all of the pros and cons of this stuff, but it's important to kind of understand, like, there's a difference between where the HTML files are being rendered, that there's a difference in which one is better than for what, and what frameworks accomplish this. So Django, while it can do, and this is something I will say right here, it can do client-side rendering. However, it's designed for server-side rendering, and you've done this before. So it's designed for server-side rendering, but you can do client-side rendering with Django. So let's do a very quick Kahoot question here. And I'll put into perspective a bit more why we're even talking about this in the first place later on in the lecture after this question. So join in with your net ID as always. Someone asked, is client-side rendering similar to how a virtual DOM works? I don't know if these two things are related, but they sound similar. I don't remember a whole bunch about virtual DOMs, but I don't think they are related. But I'd have to get back to you on that. I'd have to look into that. Okay, I'm gonna go ahead and get the Kahoot started. So it should be a very simple question here. A problem with client-side rendering is that we make very frequent requests. Is this true or is this false? False. Be careful. Okay, wonderful. So we have majority false, which is correct. I'm assuming those of you who picked true might have gotten tripped up about this right here. So the key thing to notice here is that we're talking about client-side rendering. And so we would not make very frequent requests with client-side rendering because we won't need requests to render the HTML at all. We're doing it right on the client. Meanwhile, server-side rendering will be rendering on the server side. So yes, we will have very frequent requests. So let's go ahead and get back into the Google Slides here. So I'm going to be trying something new out here. I haven't done this before, but I'm going to try and write out some diagrams with an iPad here. So let me go ahead and give this a shot, just so I can kind of put into perspective the general structure of a full stack application. Okay. So I'm just basically screen sharing to myself right now in Zoom. Let's see how this works for us. So let's talk about first the general structure of a full stack application. So when we say full stack application, what that means is, we're not essentially working only on the front end or only on the back end or a database, for example. We are working with respect to everything as a whole. And so what do I mean by that? Well, in a normal application, you can kind of expect to have something called the front end, right? You can have, of course, the back end. And so it's important to note that in the front end, this is what the user sees. This isn't just with respect to, an application. If you go to see like a show in the theater, like the front end is basically the bells and whistles right in front of you. What's going on? What are you seeing? People are dancing, people are singing, whatever. But behind the scenes, there's more work going on. There's more to the story. This is the back end. So this is like behind the scenes, right? And so the general structure of a full stack application is that the front end will talk to the back end, right? And the way that we do this is by making HTTP requests. And we talked about this a few lectures ago when we talked about get and post. So, it'll basically send a request over to the back end. The back end will send over a response. And we can connect various things to the backend. Let's say most notably a database. So let's say we have a database here. And so let's say I want from the front end, let's say I have like, a drop-down list and I select like a user and I want to add in, or actually let's make it let's change our example here. So let's say we have like adding a new user to the database. So on the front end, they would type in the new user, we would hit submit, which makes a post request to the back end. And then in the back end, we will take that JSON data that was sent to us from the front end, add it into the database says that it was added, and then we would tell the front end that the user was successfully added to the database. So, this is generally how the structure of a full stack application is working with each other. And so for a real example, we can take a look at something like, let's say we saw an example of like a COVID-19 visualization site back when we had that API lecture. So let's say we had like a graph, for example, to show off COVID-19 data. And we had like a drop-down menu where we said all of the different options of data sets that we could choose. So let's say we wanted to choose like United States data. So this is our front end. And we would have in our back end, we would have an endpoint that basically says get USA COVID-19 data. So we hit submit on the USA data. We ask the backend, can I get the data for this? The backend sends over the data to the front end, and we can take that data to populate our graph. So let's say on the front end, we go ahead and we have, I don't remember what the USA COVID graphs looks like. It looks like this probably, something along those lines. So we get the data from the backend and we plot it over onto the front end. So this is kind of the general structure of a full stack application. And so the back end will be a server. The front end is a client. And we can have multiple different front ends, multiple different clients talking to a server. Let's say this was like a web app, and I also wanted to have a mobile app. Then I would have my mobile app here, and it would talk to the same exact server that the front end talks to from the web app. So this is just generally the structure of a full stack application. I think this is important to note when we talk about a few more things. So what is a RESTful API? I want to define this before we continue before we continue and talk about a framework in Python, which we will be covering today, which is Flask. So first things, what is RESTful API? So REST is just a design pattern for creating a web API. REST is the most popular and most modern design pattern. And so a RESTful API is one that follows this REST design pattern. And you can see the principles of REST here in this link if you would like. So we have a question in the lecture questions. How does the backend and the server interact? The backend is the server. And the way that they interact, the way that they're communicating here, this is going to be HTTP requests. So that's your get, that's your post, and we'll talk about this more as we continue through the slides. And someone says, why is it called REST? REST stands for something that I actually don't really remember. It's an acronym. I can tell you what it is if I just Google it, but it stands for something, basically. So the good news here is that you guys actually already know what a RESTful API is. In the API lecture, yes, so someone actually looked it up for me. Representational state transfer. That is what REST stands for. Okay, so you guys already know what a RESTful API is. The thing is, we only have been calling them so far. So if you remember from the API lecture, we said, here are some different endpoints for a COVID-19 RESTful API. And we have the different types of requests that we can do. We have get, we have post. In the homework, you guys had delete. And so here is actually the RESTful API that we had you guys interact with on the homework. We had you guys make a GET request to this endpoint, a delete request to this endpoint, and a POST request to this endpoint. So a RESTful API is essentially exactly that. A RESTful API is just something that follows the design patterns for creating these web APIs. It's important to just know the name of it because you'll see it thrown around a lot. But if it's using GET requests and POST requests, it is following these design patterns. So an important thing to understand here, and this is what I wanted to talk about now, is what's actually going on under the hood, right? When we talked about APIs before, we basically said, we don't really care what's going on under the hood here. We just know that it's getting us this data. With respect to our homework, you guys did not really know what was going on under the hood in these endpoints. We just knew that we were making requests to an endpoint and you guys were getting hashed data back, right? So in other words, all we've done so far is we've had an API, we've been making requests to it, it's been sending us data back, but what's actually going on in here? How do we make one ourselves? And the reason why this is important is because we've kind of showed you guys already, how to make front ends in some sorts. With Django, everything is sort of wrapped together. But how do you guys go about making a backend? So here is actually the code for our API that we made for the homework that you guys had on APIs. This is the API that you guys actually interacted with. Now it's important to note that this is actually written in JavaScript, in Node.js. That's not really important because actually when we go forward and we talk about Flask, you'll notice that the code is actually quite similar. You have these different endpoints. So you remember first we had the GET request. So what's going on under the hood here is we have this JavaScript library named Express that essentially is listening for requests to come in. Once we get a request on this endpoint, so /APIs v1 users as a GET request, we'll fire off this function and we'll hash the data that you guys put into the query parameters and we'll send back a response. That's basically what's going on under the hood here. And so each one of these endpoints have some computational logic under the hood. This is what we're going to be talking about today. How do you make your own backend with a RESTful API? So back to our little diagram here. Essentially, what we're saying is, here is our backend. How do we make one, right? Someone says, do you have to pay to host the API and stuff? It depends. Yes, in a lot of cases. The answer is yes. But sometimes you'll have free tiers where you're missing out on certain, functionalities. But usually you can just run them locally, which I will be doing for this lecture. So let's go ahead and talk about how to make a RESTful API. And the RESTful API that we're going to have today is going to serve as a backend for some sort of web client. So let's say our website is going to be getting data about books, essentially, right? This is my website. This is my front end. And I want to make a backend. I want to make a RESTful API that will serve my front end information about books. And so what does that mean? Well, here I'll have a database. This is my DB. And so from the front end, if I basically say, give me a list of books, I just want a list of books. So I'll make a call to the backend. This is our server. And I'll say, get request. Get me a list of books. I'm going to be calling an endpoint that gives me a list of books. The server will go into the database. It'll say, make a query that gets us a list of books given the parameters that the front end gave me. The database will give the information back to the server, and the server will say, okay, here is your response. Here is your information. And we can throw that list up on the website. And so if I want to, for example, add a favorite book to the database or something, I can make a POST request to the server with the data, it'll add it to the database, and etc. So now let's talk about how we could do this using Flask. So what is Flask? Flask is a web framework for Python, meaning that it provides functionality for building web applications, including managing HTTP requests and rendering templates. So what's important to note here is that Flask can do essentially a lot of the things that Django can do. But what's important to realize is this. So whatever happened to Django? Well, Django has a very set project structure, and it includes many built-in tools. This can save time and effort for experienced programmers, but it can be very overwhelming in general. So Django is much less lightweight than Flask. And so Flask applications tend to be written on a more blank canvas and are much suited for a contained application. So if we wanted to, for example, write a backend using Flask, we could do this in Django too. It's not like Django doesn't allow us to write a backend. We can do that. But there's a little bit more of a higher upfront cost than what you'll have in Flask. And you'll see that once we actually start looking at some Flask code. The cost of writing Flask code is very low upfront. It's about like 5 lines of initial code to start up a Flask server, and I'll show you that. But essentially, the reason why we were talking about client-side versus server-side rendering earlier in the lecture is because if you wanted to have, like, for example, your Flask backend serving information to a front end that's written in like JavaScript, HTML, and CSS, you would want to have, the ability to render the HTML on the front end. So this is our front end client. And you would want your back end to serve a different purpose than what, Django typically has. Oh, I'm getting an email. Whoops. Okay. So let's go ahead and make this distinction here. So for this lecture, we are going to be using Flask to write the backend. So Flask is extremely lightweight, and it's awesome. So let's write an API using Flask. Very simple demo to start with. So here is the boilerplate for writing a Flask application, for writing a Flask server. So what's going on here? In order to make an endpoint using Flask, all you really need to do is import it in and just write it on top of a function. Just have this annotation that basically says on top of the base URL, which is localhost in this case because I'm hosting it locally on my computer. So you can see the URL down here. Whenever a user calls that URL /users, we want to trigger this function. And that's all Flask is really doing in this case. It's just basically serving as a way of reading in these requests, firing off this function, and sending a response back to the person that called it. So here's an example of a very simple endpoint called users. And when you don't say what HTTP method this endpoint is, Flask will default to get. So this is going to be a get endpoint. And so in this case, we would just have, the information that we want to return or, give a response to, and we send it in terms of JSON. Normally, you would want this to come from a database, this information, because of the way that REST design principles are. But in this case, I wanted to show how simple this is in Flask. How little boilerplate that you need. This is like 5 or 6 lines of code. Super, super simple. So the upfront cost of writing something in Flask is very, very low. So now let's talk about that API that we were talking about with the books. So here is an example of how we can use Flask to write a backend for our book website. So now let's say we wanted to have an endpoint that gets us a list of books based on a set of parameters. I can just put on this tag, which basically says whenever this endpoint is called as a get method, we're going to fire off this function. And inside of this function, due to Flask, we can very easily retrieve the information that was stored in the request to the backend. So here, for example, this endpoint takes in some query parameters. So our query parameters are like the ID of the book, when the book was published, when the author, who the author of the book was. So we send it in through these query parameters, and we can retrieve them with this syntax here. I don't want to spend too much time explaining Flask syntax because it is quite easy to follow. But this is essentially what's going on here. And so we can connect it to a SQLite database similar to what you guys saw in Django. And we can query the database given the parameters that was sent in the request, and we can return the results that the database sent us. So let's take a look at an example here. So if I wanted to call this endpoint that we have right here, the same way that we were calling endpoints when we were working in that API lecture, where we were calling endpoints for COVID-19 data or the dummy data from that website. Let's say we called this endpoint in the same exact way. We just did a GET request on this URL here to get us a list of books. So if I did Python 3 get underscore books.py, you'll see that it is querying the database, and we're getting a bunch of books with a bunch of different information. And I can put this into a JSON formatter so it's actually easy to read. Or I can do another thing, which is, so someone actually asked a question about this. What would happen if you put the API URL into a browser? Well, this would happen. So if I went ahead and put that same exact URL for that endpoint into the browser as a GET request, so right here, you'll see that it will return me the response from that GET request right here. And it'll give me all of the different information that we retrieved from the database. So as you can see, we have all these different books. We have author, ID, when it was published, and the title of it. And so if you have the base URL here, if that's what your question was about, you'll see that we can actually, this is actually in the code. So the base URL, if you're not signifying an exact route, you can have Flask just sort of default to dummy data to just explain what this API is doing, right? So this is a base point for the API. Let's go backwards here. So I wanted to note this because it's important to realize that this data, when it stands alone, is totally useless. But now imagine if inside of this Python code, I took this data and let's say, for example, within a full stack application, I said on the front end I wanted to have, like I said, a list of books. And I called the backend with that GET request. I would essentially just call that URL the same way that I did in Python here. And when I get the response back, I would put the data onto the front end. Okay. Do we have any questions about this? I would love to hear some questions. So someone said, wait, what would be the code for that? To pull the data into the front end. Okay. So I can't really show this to you live right now because I would need to write up a front end basically for this. But on your front end, you would essentially just make a request and put the data onto you would literally retrieve the data. Once the response is sent back from the backend, you're able to plot it, for example, on the front end. If you did this with a website, if you did this with a mobile app, the code would be respective to what framework or programming language that you're using. So if you were writing an Android app in Java, in your Android Java code, you would make that request, get the data, and use it however you would like. What would happen if you ran get on the root URL in Python since it returns HTML and everything? Well, you can see what will happen. So it'll actually error here because it's expecting JSON, but maybe if I actually just say text here, because it's not returning JSON. Or rather, here. Yeah. We'll just see that like it gives us a response, basically. Can data be pulled directly from the API to the front end, or does it have to go through a database? So you don't. So the question is, from the API to the front end, or does it have to go through a database? Well, you need to store the data somewhere. You shouldn't be storing the data on the back end here. You should not store the data on the back end. This is one of the design patterns of REST. You don't want your backend to store any state. That's why you put it in a database. So technically, yes, like you're allowed, like you're not going to be stopped by your code or something if you wanted to pull data into the front end directly on the front end or directly on the back end. But just the way that convention is, you would want to go through a database. What is the recommended framework for us to use if if machine learning is involved? So that depends on what you mean. Do you mean like what framework should you use to accomplish machine learning, or what framework should you use to write your backend in? Because for machine learning, a great framework in Python that we talked about in the lecture last week is scikit-learn, and so you could put that to write the backend in. Okay. Yeah, I mean, what you could do, for example, for like a backend with machine learning, is you could literally have like a Flask server, for example. Wow, my handwriting is terrible. Flask. You could have a Flask server, for example, with like scikit-learn tied in to it, or whatever ML framework that you're using. Whatever ML framework that you're using. The whole point of writing a backend isn't that you're like restricted to do what you're able to do whatever you want within these functions. The only thing that you have to note is that you are getting data and you are sending some sort of response back. Whatever you do inside of these endpoints is totally up to you. If you want to run some data that you retrieve from the front end through a machine learning model in this endpoint and return a response, that's allowed. You can totally do that. So it seems like that is a majority of the questions, I believe. So we have a few more things to talk about. What is the difference between text and JSON? So that's specific to the requests library. But long story short, it's just the way that it parses the data that is returned from the request. One will get you just the pure string. Like one will only give you just a string with the response, whereas JSON will actually be able to structure it into a Python dictionary, and you'll be able to do like dot notation on it, things like this. So I wanted to go and talk about, once again, the client-side and server-side rendering. So you can do server-side rendering with Flask, just like you can do server-side rendering with Django. Same way you can accomplish client-side rendering with Django, you can also do the same thing with Flask. So how would you do server-side rendering with Flask? Well, you would just add in a new endpoint that does this right here. There's a function inside of Flask called render template, and you can render the HTML here, and it'll send a response back to the person that called this route here. So you can use Flask to actually do server-side rendering if you would like. Okay. So that is all of the slides that we have for today. I just wanted to basically give you guys some intuition on like how things are separated from each other within a full application, how things like Django and Flask differ. you can accomplish exactly what we talked about today in Flask, writing these endpoints out. You can accomplish this in Django. It's just a bit more of like an upfront cost than what you would have with Flask. How would